All right, hello everybody. My name is Jim Pingle. Uh, Welcome to our May 2016 Hangout for NAT on pfSense 2.3. Got a bunch of good stuff coming up this month. A little bit of an overview of what we're going to be talking about today. First up, as always, we got project news. We'll talk a little bit about what NAT is, what it does to packets. Talk about inbound NAT, things like port forwards of one-to-one NAT, whether you should use it, and if you decide you should, whether you can use it. And we'll talk about how to choose between using port forwards or one-to-one NAT, and we'll talk about what port forwards can do in terms of their capabilities. I'll walk through an example of a port forward. I'll show you a couple of others that I've got set up here too. Same thing with one-to-one NAT. We'll go over capabilities in an example. We'll talk about NAT reflection a bit, maybe a little bit about split DNS, not like a walkthrough or anything, but we'll go over it. Talk about outbound NAT, various ways you can control traffic with outbound NAT. Talk about the different outbound NAT modes, what it can do, and a couple of examples of things you might want to do there. And do a brief little bit on troubleshooting. We have a whole previous hangout on port forward troubleshooting that's really informative if you still need help by the end, and a little bit of time for Q&A. So that should be pretty well it for this month, and we will keep on going. First up is our project news for this month. Just waiting for the slide to come up here. Okay, the project news for this month. You probably have seen already our 2.3.1 version is out. The release is out. It was a maintenance release with fixes since 2.3. There were some things that people found with the upgrade, some problems with upgrading, or with things that were not quite right after you've upgraded. And even since then, we've also put out a 2.3.1 update one with a security update there. Some good things to have, so you want to make sure you get fully up to date. If you had tried 2.3 and you thought something didn't go quite right and you're still on 2.2, it's worth another shot. But it's good to get up there. And if you're already on 2.3 release, you want to make sure you get up to 2.3.1 update 1 as soon as possible. We got a little device called a micro firewall we're working on. It's been teased a little bit on Twitter from Jim Thompson's Twitter feed. We've got a link to a couple of statuses here about it. It's a little ARM-based board that's going to run pfSense. It's really small. It's only about 77.5 millimeters by 43 millimeters. It's got two real Ethernet interfaces, which really sets it apart. And there's also a similar board we've got coming called MicroBMC. It's an ARM-based solution for out-of-band management, sort of like IPMI, things like that. Be able to do things like power control, fan status, and so on and so forth. And there's another link to Twitter for that as well. We do have a pfSense test build already running on that. It's very early stages. A lot of rough edges we need to work out, but that'll be coming in the very near future. On the convention scene, Netgate and pfSense were both at Interop in Las Vegas earlier this month, and then or between last month and this month, and then OSCon. Also, we have BSDCan coming up in June. So if you're going to be at BSDCan, be sure to stop by and see us. pfSense is now live on Azure. The process was started so long ago. It's version 2.2.5, but we'll get that updated as soon as we can. There's just a lot of bureaucracy to go through. But now that we've got approved and everything's on there, things will be coming up very fast. And as always, we've got our obligatory online training schedule plug here. We do have the schedule up for the rest of the year. If you're interested in training, just go to netgate.com/training, and we have plenty of spaces left in classes throughout the rest of the year. Okay, so first we're going to talk about what is NAT. Very basics. It's something you may take for granted, may not always realize it. NAT is network address translation. Strictly speaking, a lot of what you normally call NAT is actually port address translation, or PAT, because you're translating the ports of the traffic as it leaves and doing sort of an overload style NAT. In the strictest sense of the word, NAT literally just means changing just the network address, so it's more like one-to-one NAT. but it's used. The terms are used interchangeably. So anything I just say as a NAT, it's going to be any sort of translation, including port translation. So your port forwards and inbound NAT is also known as destination NAT or DNAT in other projects or things. It's called that because it changes the destination address of a packet as it comes into an interface. And it's important to note that the port forwards and inbound NAT take effect on the way into an interface. So, obviously, if you're port forwarding something that's coming from the internet, you're going to put these rules on a WAN because you need to grab it as it enters the firewall. Outbound NAT is the opposite. It changes the source address of a packet as it exits an interface. So again, it's important to note that that only happens as it leaves. It doesn't make any sort of routing decisions or anything like that. It just it says, oh, this packet's already leaving here. I need to change the source address before it goes. And so the typical use of NAT is to allow any two networks with no direct routing to reach each other without tunneling. So it's sort of something that a lot of people take for granted, that you have to be able to present traffic as if it's from a network that can be reached on the other end. So obviously, if you're port forwarding, somebody on the internet can't reach your private, say 192.168.1. whatever address directly. So you have to have them talk to the public address and then translate that to a local address on the way in. Same thing with the way out. An internet host can't route back to your private network. So you have to present that traffic as if it came from your WAN address, because that's the address they can actually route back to. You can also overcome some things where you do have routing connectivity, like a VPN. So your LAN subnets conflict, or you've got a conflict between two different remote networks that you connect to, but not a direct conflict locally. You can use NAT to work around or overcome conflicts like that, at least in the OpenVPN case, and somewhat also with IPsec. One little other thing that's important to note, but doesn't really fit in well with any of the other slides I've got. NAT is processed before firewall rules. Like on the way in, packet comes in, for a port forward, for example, the NAT's going to apply before it gets to the firewall rules. So when you do write firewall rules, it's going to be using the translated destination. Similar with outbound NAT, you'd almost never need firewall rules for outbound, but in the case that you do for a floating rule on outbound NAT, for floating rules with outbound NAT, you need to make sure that you capture filter based on the source being the public address, not the private address. So you can't say have your LAN being translated to all one WAN IP and then also have a floating rule outbound on WAN that filters based on the internal LAN address. That won't work because the NAT's happened by the time it gets to the rule. All right, talk a little bit about inbound NAT here. So we're talking about inbound NAT. I'm just meaning port forwards and one-to-one NAT because they can both, have effects on the inbound direction. So they both accept traffic in. They both will take a request sent to the firewall from the outside and forward it on to a new target. So with any of these NAT entries, you're going to have three components, which the first is the source, which is the initiator of the request, the client, which typically with port forwards is going to be something remote to you out on the internet. You're going to have the destination, which is going to be the firewall in this case, or pfSense in most cases. And that's going to be the original IP address that the client sent the request to. So the client makes a connection to your WAN address, then that hits the firewall, and then that gets translated to the actual destination, which is the target server, which is the local machine on your local network where the actual request ends up going. And then, when that responds, it'll go back to the firewall and back the other way and be retranslated and sent back out. And just to reiterate this, when you're talking about firewall rules with these, an inbound NAT, you always have a destination of the private IP address of the target after NAT. So if you need to allow something in for a port forward or one-to-one NAT, your destinations are always going to be the internal addresses. So talk a little bit about security-wise here. Should you use inbound NAT? And it's something you need to consider. A lot of people take it for granted. They just open up a port and just let the world into anything they've got. But you don't want to take exposing a service like that to the public too lightly. You need to make sure you consider all the security aspects of it. Because if you do expose anything on your local network out, it's an immediate security risk. So if somebody were to compromise that server, they could gain information not only from that server, but they could use that server as a launching point for other attacks into your network. And that's why we usually recommend things like that be in a DMZ, on their own separate isolated subnet away from your local network and other sensitive devices. But that's not always practical, especially for small networks. If you're interested in doing something like that, we did have a hangout a couple of months back about making a DMZ, so be sure to check that out if you're wanting to pursue that in a more secure way. So when you're allowing these things, if it's a publicly accessible service like a public web server, that's fine. But if you're talking about something with private resources, like a DVR camera, SQL server, RDP, file sharing, things that are going to have sensitive data, you don't want to expose those to the world. So you really, when you do that, you need a more secure method like a VPN to get into them. Don't do something like that with a port forward. You can do source restrictions in some cases that'll let you limit your risk there. That's really still not a great idea. If the service is encrypted, it's not too bad, but you really don't want to expose that protocol to the internet, because there's always a chance that somebody could find a way in there. And you're better safe than sorry. Just leave that stuff for a VPN. And lastly, it's something we see every once in a while. You don't need port forwards to reach services on the firewall itself. There are some exceptions to that, like if you're doing a special configuration for like OpenVPN and multi-WAN, or you're port shifting for a proxy, like say you've got like Squid reverse proxy or whatever, bound to port 8080, and you really want to have it accept requests on port 80, you can port forward, from 80 to 8080, because you're actually doing some translation there, and that's necessary. But if you're just trying to open up remote access to your GUI or SSH for a remote management, you do not need a port forward, just add a firewall rule. So after considering if you should use it, you have to figure out if you can use it. One of the most important things to know is if your firewall has a public address on its WAN. If your firewall has a private address, you need to worry about forwarding upstream from you as well. So say you want to forward port 80 into a web server, well, whatever's ahead of you has to forward port 80 into you, and then you could forward that on to another web server, but you have to be able to accept those packets from the outside. So if you don't have an upstream, if you have a private address on your WAN and you don't have any way to control what's upstream from you, such as when you're on a carrier grade NAT type situation, typically you might see that with like 3G or some DSL lines or whatever. As IPv4 pools get exhausted, you're going to be seeing that a lot more, where you're not going to be able to accept this inbound traffic. And if you're in that situation, it doesn't matter port forwards 1-to-1 NAT, whatever, you can't use it because you can't accept that inbound traffic. And similarly, if you have a public address on your WAN, your ISP could be filtering the inbound traffic. They could be stopping certain ports from reaching you, especially low ports. Some ISPs like to only allow traffic in on high ports. That's something you don't really know until you get around and try it locally on your ISP. And another thing to consider is the destination of the traffic coming into your firewall. If it's not, you're going to have to add a virtual IP address to signal to the upstream that you are able to accept traffic for that other address. In a lot of cases, that's either handled with a virtual IP, or it may be that they've routed a subnet to you, and routing is fine because you don't really need a VIP for that. But we'll talk a little bit more about VIPs when they come up. But if you need a virtual IP address, like to expose something at layer 2, like if you're trying to accept traffic for another address that's also in your WAN subnet, typically you'd want to use an IP alias VIP, or if you've got an HA cluster, you'd use a CARP VIP, or if you've got a block of them you want to set up, a proxy ARP VIP can be easier for that. But if you have a routed block, you just need an other type VIP, or in a lot of cases you don't even need a VIP at all for a routed block. A few more things to consider about whether or not you can use Outbound NAT. You have to consider if the target is local to the firewall. And if it is a local target, like say something on your LAN network, that target system has to use pfSense as its default gateway. So if it doesn't use pfSense as its default gateway, it's going to send that reply packet out through some other router, and it's not going to make it back out. Or if it does, it's not going to have a state. It'll get broken. The connection will just not work. So the target system has to use pfSense as its default gateway. And you can use Outbound NAT to mask the source to work around that. It's just not very nice because you lose the source address of the traffic. It's just better all around to have the target device use pfSense as its default gateway. Another thing you have to look at is in the network configuration on that device, it has to have a proper subnet mask. If the subnet mask is way too wide or too narrow, the firewall may not be considered in its subnet locally, so you can't reach it. Or if it's too wide, then it may think everything is in its subnet. And a request may come in from the internet, and the server's going to start ARPing to respond back to it, and that's just not going to work. And obviously, the target system has to be configured to accept connections. So that, if it's got a local firewall on there, like IP tables, Windows firewall, whatever, that's going to have to pass in the traffic. You also need a local daemon to actually be listening. So if you've got a web server you're forwarding into, Nginx, Apache, Light HTTPD, whatever, it's got to be listening on that port to accept those connections. Now, if your target isn't local, if it's remote, like say across a VPN or remote over WAN, you can still do it with some extra consideration. It's just not ideal, at least in the WAN case, especially not ideal. You have to use Outbound NAT to mask the source so the traffic will come back to the firewall. And that kind of requires a messy rule with the source of any, it's kind of messy to do. I mean, if you really had to do that, that's something, it takes some careful crafting of rules. We've helped people do that before. It can work, it's just not great. It's best to avoid it if you can. You can do it across a VPN. Just depends on your configuration of the VPN. If it's open VPN on both sides, it's actually pretty easy. You just assign the VPNs on both sides as interfaces, set your rules just right, and then the return traffic will just flow right back the way it should, and everything will just work. It's really, really nice. IPsec is a little bit tougher because you can only do that if all of the traffic, like 0000/0, going to your target address, it's got to be on the tunnel going that way, which means that everything coming to and from that target address is going to have to come over your VPN as well. So you couldn't accept connections in that case on the target server from both the location across the VPN and the local firewall. Whereas with OpenVPN, it works fine from either direction. So it's a lot better with OpenVPN in that case. But either way, it's kind of a rare need. But we have seen, especially the OpenVPN case, get used some with data centers and disaster recovery type situations where they need to be able to, hop traffic over across a VPN if they need to. All right, so say, you've decided you really want to use inbound NAT and you've decided you can use it, everything's configured right on your local network. Then you just have to decide whether or not you want to use port forwards or one-to-one NAT. And they can both accomplish the goal, but it depends on which one you want to use, to make your life easier. So the first big question is, how many ports are you forwarding? If you've only got a couple, or they're all in a tight range, or you already have an alias of all your ports, then port forwards are easy enough to do. But if you want to forward like thousands of different ports or just everything, one-to-one NAT's going to be easier. Another consideration is which protocol. Things like TCP, UDP can be done in port forwards, but there might be some less common protocols that we may not have an entry in port forwards for. Then to get that traffic in, you may have to use one-to-one NAT. Another consideration is outbound needs. So if you need to have NAT coming in on a VIP to get to this local server, and you want all your outbound traffic from that server to leave with the VIP, you could do that with port forwards and an outbound NAT rule, but it's easier to just use one-to-one NAT and kill two birds with one stone. From a security standpoint, there's a minimal security edge for port forwards. With one-to-one NAT, you could slip up with your WAN rules and allow more traffic than you intend to reach your local device. But you can also make an overly permissive port forward, so it's kind of a toss-up there. But there is a slight security edge for port forwards, but It's usually so slight that it's only worth mentioning. It's not really a giant concern. It's just something to keep in mind. If you have a tendency toward accidentally making rules a little bit too lenient, then or if you have a client that likes to add like an allow all rule on their WAN, then well, that would not be ideal. Something else you can do if you're trying to work around LAN subnet conflicts, like I mentioned earlier, especially with OpenVPN, you would use one-to-one NAT. You would not need that for IPsec because IPsec you would define that NAT in the phase 2 settings. So really, the only time you consider using any type of manual NAT rules, whether on port forwards or one-to-one NAT with a VPN would be in the OpenVPN case, and in that case, you'd almost always be using one-to-one NAT to basically hide your LAN behind some other non-conflicting LAN. Okay, so now I'll talk a little bit about port forward capabilities. The slide ever switches here. All right. So what port forwards can do, you can forward a single port, or you can forward a contiguous range of ports. So say you want to forward ports 10,000 through 20,000, like for RTP for VoIP, you can do that very easily in one rule with a port forward. The target range that you're forwarding to has to be the same size. So if you forward 1,000 ports on the outside, it's got to be 1,000 ports on the target as well. Every once in a while, we'll get somebody asking something crazy like, well, can I forward 100 ports on the outside, just all into one port on the inside on one box? Which A, I don't know why you'd really want to do that. B, you can't do that with at least with the way PF does NAT rules. So you define your port range on the destination, and then you define the starting port on the target. You can still shift, like you could forward 1,000 ports starting at port 5,000 on the outside, and then you could translate those over to port 7,000 on the inside if you wanted. The cases for that are a little bit more rare, but it's still something you can do if you had to. More often than not, you're just going to be forwarding a single port on the outside to a single port on the inside, or a small range on the outside to the inside. Or if you're translating a port from one to another, you just have one port involved more often than not. You can use aliases to forward a set of ports. You might be able to see in the background over here, I've got like in mail ports alias, I've got, with a bunch of different ports that are involved in email. And as long as you have to use the same ports in the destination and the target, the NAT ports here, but you can use an alias to speed that up. And that can be really, really convenient, especially with a good set of ports like that, where it cleans up your rules list a lot, and it also makes it sort of self-documenting. Something to note, a little restriction on what you can and can't do. You can only forward one port on the destination to one target from the same source. So say you've got 2 web servers on your LAN, and you only got one port 80 on the outside. If you have a port forward, say you have 2 port forwards and you put both of them on port 80, only the first one is ever going to be hit. That second one's never going to be hit. The only way around that is to make a source restriction where you have, okay, this site comes in, they hit port 80, and they go to this one, or if some other source, like from our data center, they come into port 80, they get this other server if they come into that. I kind of recommend not doing that because it can be kind of confusing, and most protocols will work fine just on an alternate port. So that specific case with HTTP or HTTPS can be solved with a reverse proxy, something like HA proxy that can do host header filtering or SNI filtering for HTTPS. But other protocols are not able to have that happen, like things like FTP or email, whatever. They don't have a host redirect option, sort of like HTTP does with the host header. So there's no way to even to proxy that, very well. Sometimes certain protocols may have an application proxy that might understand that, but it's not something that you'd normally see in pfSense outside of HTTP or HTTPS. Let's see, I talked a little bit about shifting ports already, where you can do, port 8080 on the WAN to a target port 80. Someplace you might see that is if you've got, say, a bunch of DVR cameras or whatever, and you can't change the port that their web interface goes on. So you may have to forward like 5 or 6 ports on the outside into, whatever their default port is on the inside. Another feature of port forwards is you can use them on internal interfaces to intercept and redirect traffic. So you can do things like capturing DNS requests and forward them either to, say, DNS forwarder or Unbound on the firewall itself, or you could grab those requests and forward them out to a DNS server of your choice. Like, say, if somebody had Google public DNS set on their machine, but you didn't want them to use that, you could grab all the DNS requests and forward them into your own local server, or vice versa. It's also how Squid does transparent interception of traffic, as it uses a port forward to grab traffic going anywhere on port 80 and redirects it into the proxy port. So it's pretty handy for intercepting traffic as it comes into the firewall, just on a local interface instead of a remote interface in that case. When you're working with port forwards, you can have automatic firewall rules. The default is to automatically make a rule that is linked. So when you edit the port forward, any changes you make are carried over into the firewall rule. So say you had a source restriction set on a port forward, you edit the source restriction. When you save that and update it, if it's got a linked firewall rule, then the firewall rule will update itself automatically. And I'll talk about this maybe a little bit more when I look at the example of a port forward, but in addition to firewall rules, there's also a pass style you can use. We generally don't recommend it because it does set up it just allows all traffic that hits that port forward all the way through and doesn't consider firewall rules. So it can be kind of convenient in that you don't have to worry about firewall rules, but it's not very flexible because you don't have the ability to fine-grain control that traffic. You can't, say, make an exception to the rule to block somebody like a known offender from hitting your server. All right, well, let's look at a port forward example. Now, before you get started making a port forward, one of the first things you need to do is, if you need any aliases or virtual IPs, you got to define those first. As you can see here on this firewall, I already have some virtual IPs defined. And then under aliases, I've already got a couple of IP aliases here, or host aliases, and I've got some port aliases as well with sets of ports. So you want to make sure all those are in place before, because once you start editing a NAT rule, you can't go back and edit those while you've got that NAT screen up. You'd have to have all those edits in place before you start making a new rule. All these port forward rules are processed from the top to the bottom. So if you're doing something like I said with a source restriction versus any, you want to put your more specific rules at the top, anything more general at the bottom. With port forwards, it's not quite such a big deal. That's more of a big deal for Outbound NAT. With port forwards, your main concern might be two rules that are identical and conflict if they're on the same WAN, trying to do the same port. Whatever one gets hit first, that's going to be the one that goes. So if you use the button here with an arrow that points up, you add to the top of the list. The bottom adds to the bottom of the list. You can do exceptions to port forwards, so you can have it where if it matches the traffic, it will not do a redirect. Not really something you'd want to do for most cases, but it's there if you need it. Your interface is going to be a WAN, generally WAN 2, whatever, but it's going to be wherever you're receiving this traffic, and odds are it's going to be remote from an internet host, so you come into WAN. Protocol depends on what you're using. Like if you're doing a web server, it'd be TCP. If it's PBX, it'd be UDP. You have to find out what your service is actually going to be using. Odds are, vast majority of the time, it's going to be TCP, UDP, or TCP/UDP, which does both at once. There are source options here. If you need to do a source restriction, you can do that here in the source line. The source port, never touch that. It's not something almost anybody would ever need because source ports are usually randomized, so just leave that blank, don't touch it. Destination here you can see is our WAN address, but in this drop-down we also have access to our virtual IP addresses. So you can either do that, or you can also set it manually to an address if you're using, say, a routed block that has an IP address you don't have a VIP for. You can set that to something else. Destination port range, this is the port on the outside that the traffic is coming into from the client. And you can either pick a well-known port from the list here, or you can set it to other and enter your custom port or custom port range. If you're doing a range, the from port is the lower port, to ports the higher port. So like for example, if you were forwarding an RTP traffic, you do like 10,000 to 20,000. Redirect target is going to be your actual local device that's receiving this traffic. So it would be, say, your local web server, your local PBX, whatever you're forwarding into. And your redirect target port, again, you have a choice of a well-known port or set it to other and use a custom port. Most of the time, this is going to be identical to the destination port. If you did use an alias here in the destination port range, it does have to be the same alias here in the redirect target. And there's not a real good visual indication as there was on previous versions, but if you start typing an alias, you'll see it does allow you to pick your list of ports there in the port ranges. You can add a description for your reference if you want. If you've got an HA set up and you don't want it to sync, you can check that box. Most people just ignore that. NAT reflection I'll talk about in a bit. You can override the NAT reflection settings on a per rule basis. We don't usually recommend doing that, but you can. But I'll go over what NAT reflection is here in a bit. Your filter rule association, that's what adds the linked or unlinked firewall rule, like I mentioned, or sets up the pass rule on RDR, or the redirect, the port forward. Vast majority of the time, just leave this on add associated firewall rule. It'll handle everything for you. You don't have to worry about it. Let me show you just a quick example here that's actually live and working. This web server example, I've got the interface on WAN, set for TCP. There's no source restriction, so just from anywhere. Coming in to hit a VIP on my WAN, it's just forwarding HTTP into my local server of 10.3.0.15, redirecting to HTTP. So see it again, same on the inside and outside. And it's just a web server test. And filter rule association, because I've saved this and it has made the linked rule, it's showing me that there's the rule there, rule NAT web server test. And if you click view filter rule, it'll take you right to that rule. So after you've saved this, you want to pop over to your firewall rules and just check it out and make sure it looks right. Sorry, in this case, it is, you can see from a source of anywhere coming into our local target server on port 80, and NAT web server test is right there. And you see, I've got the separator bars here on the rules. You can have separator bars on NAT. I just didn't have any in this example. So you can add a separator here. Say I want to add PBX. And then you can save. And now I've got a header in there for PBX. So I mean, if you wouldn't really need that for like 4 rules like I've got. But if you've got some more rules, you might want separators to sort of categorize them a little bit, give you a little visual separation. We'll talk a little bit about one-to-one NAT here now. And that's just over here on the one-to-one NAT tab. So with one-to-one NAT, you can operate on a single address or a block of addresses on subnet boundaries. So commonly you'll see this with just single addresses. If you're doing like I've mentioned with VPNs, when you're masking a whole subnet, you might see like a 24 block at a time. In rare cases, when you have a whole public subnet that maps nicely to an internal subnet, you could do one-to-one NAT for an entire subnet that way as well. It's pretty flexible. It forwards all ports and protocols sent into the destination onto your internal targets. So anything that comes in, whether it's a connection to a port, whether it's a protocol that is known to the firewall or not, it's going to get forwarded in. And traffic on the way out, leaving from your local host, is also going to be sent using that address on the outside. So if you've got a virtual IP you're using with this, traffic coming into that virtual IP is all going to be tied locally to that local server. Traffic leaving from that server is going to leave as if it came from that VIP. So it's really tying those together, like the name says, in a one-to-one fashion. Source ports are all kept static. So the one-to-one NAT works really well for things like a PBX. If you have a VIP to assign to a PBX, and for some reason you can't use the public routed addresses locally directly on the PBX, doing one-to-one NAT really sidesteps a lot of the problems you can have in a case like a PBX especially. It's also handy for like mail servers, because you need to make sure that your mail traffic leaves from the same IP address that it enters on, because your reverse DNS has to match, and it's got there's a lot of particulars with mail that can get sidetracked as well. Especially if you try to have traffic come in on one IP and leave from a different one, it's not very nice from a mail server standpoint. So it really comes in handy for things like that. Now, just because the one-to-one NAT will translate all this traffic in, but you still have to allow it through with firewall rules. So you still need to have those manual rules that you put in. They ought to be done by hand. There's no automatic rules with one-to-one NAT because there's no way for it to automatically know what you want. And even though one-to-one NAT is basically a port forward for everything in plus an outbound NAT rule internally in PF, you don't need to define them separately. You just do it with a one-to-one NAT. It saves you a lot of headaches by just doing one-to-one NAT rather than having to keep track of both the port forwards and the outbound NAT separately if you want. Another thing, another term you might hear used around one-to-one NAT with some especially Soho gear. Some things like to call one-to-one NAT on the WAN address a DMZ, like you might see a quote-unquote DMZ feature that you plug in a local address and it will forward everything into it. It's not really a DMZ in the technical sense, but you can do that as in a one-to-one NAT on the WAN IP address to pfSense. You can do that, but we don't recommend it because it can cause you trouble, especially with things on the firewall like VPNs. Because you could initiate a VPN from the firewall in that case, but if you were receiving a connection from the firewall, you'd have to set up some exceptions to that NAT. It gets kind of ugly. Otherwise, when that VPN connection comes in from remote, it's going to be forwarded onto your internal host. It's not going to stop at the firewall. So while you can do one-to-one NAT on the WAN address now, we generally recommend against it. I got a couple of quick examples here for one-to-one NAT. Just like with port forwards, you want to define your VIPs first if you need them. And then you just come in here to Firewall NAT on the one-to-one tab. I'm just going to edit one of these two guys here. You can do exceptions here with the no by NAT. You normally would only use that, say, if you're doing one-to-one NAT for an entire subnet, but you have one or two addresses in that subnet you don't want to one-to-one NAT, you can make exceptions that way. Most of the time, you're just going to leave that alone. You're not going to touch it. The interface there is always, again, going to be a WAN, either WAN or a WAN. If you're doing the translation on a VPN, that would be, on the VPN and Open VPN interface. Your external subnet is the subnet that is on the interface you're talking about. So since our interface is WAN, this external subnet is our VIP on WAN. It might be an IP address in a routed block coming in WAN, but technically speaking, that address is actually presented on WAN. So you kind of have to line those up. One-to-one NAT with the internal destination nomenclature we're getting into here can be kind of confusing because the way it's worded is traffic coming into the firewall, but it also applies in the opposite direction. So yeah, the external address is the address that's on the interface that you're talking about. The internal address is your local host, on your local network, on the other side of where this translation is going to be happening. And the destination could be a filter. It's in the destination sense, it's the outbound sense. So if you are wanting to limit your traffic, say you only want one-to-one NAT to apply from your PBX only when it's going to your SIP servers, you would put that destination restriction here. And then when traffic leaves from your PBX, goes out your WAN, if it's going to the SIP server, it would have one-to-one NAT applied because it matched that destination filter. Now, most of the time, this is going to be any, but you can set that up if you want to have to make better use of a limited number of external addresses if you have them. Now, in the opposite sense, in the inbound sense, that's actually going to be the source of the traffic. So say you did have that same restriction, say it's a PBX and you have the destination filled into your SIP servers, traffic coming in from the internet will only trigger that rule if it matches that destination field coming in as the source of that inbound traffic. So it's kind of a confusing term there, but there's not really a better way to say it. I guess it could be a remote restriction instead of a destination restriction. So something to keep in mind there if you want to do any sort of restrictions on when the NAT should happen. But again, most people, you're not going to use it. You can drop in a description there if you want and set up NAT reflection. I know I've said quite a lot here, but for most people, all you have to do is choose the interface, pop in the external address, pop in the internal address, save, and you're done. And then add your firewall rules. Now you see here I have, under port forwards, I've got this PBX example for PBX1 on WAN and WAN 2, and I've got this mail server here on this 213 IP address, and it's using port forwards. And over here on one-to-one NAT, I've got this on a 214 address going to a different mail server and on a different VIP going into a second PBX. So you can see kind of where my examples are going there. So if we come over here to rules, you'll see this traffic. These are the rules on WAN, and that's where all my one-to-one NATs were on WAN. There's the rule from the port forward. And the rule for the one-to-one NAT looks very similar. I've got it set with a source restriction for the SIP servers, coming into the local address of my second PBX, and it's passing traffic coming into the PBX ports. So you still have that fine-grained control with firewall rules. And similar here with the mail server port forward and the mail server one-to-one NAT. I've got them both here. The rules look nearly identical for when we were allowing that traffic in. And just to quickly show you on WAN 2, the only thing I had set was the PBX1 on WAN 2. And you can have port forwards on the same ports on different WANs coming in like this, and they can be active even at the same time. I touched on that a lot more in the multi-WAN hangout a few months back, to showing where you can have inbound traffic coming on multiple WANs. And that works just fine as well. It's just the only place you conflict is if you're trying to do the same port on the same WAN. All right, well, I've danced around NAT reflection a bit, so let's talk a little bit more about NAT reflection. That's under System Advanced on the Firewall and NAT section, and there's a whole section here on network address translation. So what NAT reflection does, it allows your local users on your local networks to access resources using the external addresses, like the destination of a port forward or one-to-one NAT. So your port forwards, as I mentioned earlier, they're only triggered by traffic entering your WANs. So if a request comes from your LAN going to the firewall, it's not going to be entering your WAN, so it will never hit that port forward. It's a little confusing for people. They're like, well, I've got an entry there that's supposed to forward that port. Why doesn't it work when I come from the inside? Well, it's because that rule isn't on that interface. So reflection adds rules, or in some cases a proxy daemon, where it will accept that connection in your local interface and bounce it back out. Now, it's not really desirable because you have all these connections that are flying around between your LAN and your local server. And if they're on the same subnet, there's no reason for that traffic to hit the firewall at all. So, reflection involves the firewall in a connection that doesn't need to be involved in. So it consumes resources on the firewall, having to handle these connections either in rules or with a proxy daemon. And it's not ideal because it just doesn't have to happen. It's putting an undue burden on the firewall. And for some people that may not matter, especially if it's a lightly loaded thing. But if you have a server that gets used heavily, it's really going to add to the burden on the firewall. So what kind of can trip up NAT reflection a bit is that, if your client and server are in the same subnet, it needs some special handling. Otherwise, you're going to break the flow of traffic. So your client sends a request to the firewall, and then the firewall bounces that back to the server. If the server sees the actual source of the address or source address of that traffic being the client, it's going to respond directly back there. It's not going to send that traffic back through the firewall. The problem is the client sent that address to sent that connection to the external address. The server replied from the internal address, and the client doesn't recognize that packet. It's going to say, "Hey, I didn't send for that. You're trying to break my connection or break into it, intrude on it, whatever," and it's just going to drop that packet because it doesn't match. So it has to have extra rules that will mask the source of the traffic. So the client goes to the firewall sends the traffic to the server and makes it look like it came from the firewall. That way the server responds back to the firewall back to the client. So for every packet that gets sent, it's going to hit the firewall twice, once on the way, or for every connection, transaction, it's going to go client, firewall, server, server, firewall, client, even though they're in the same subnet. So the better way to handle this is split DNS. What that does is, if you're inside your LAN, you have a host override or something, so you resolve your local servers to their local addresses, and then everybody outside resolves it to the public address. So just a quick example of split DNS, like here on my workstation, I've got this testreflect.example.com, and it resolves to an external address. And if I go over here, I've reached that web server, testreflect.example.com. I did it by host name, and just to show you by IP address, it works there too. However, from the inside, I've got a client here. This host is on the LAN behind that firewall, and it sees testreflect.example.com as a 10.3.0.15 address, and it goes there, and it can hit it just fine because it's hitting the local address, and that doesn't consume anything. But also, just to show you that NAT reflection is working, you can go there from the external address. But had I turned off NAT reflection, that external address link attempt wouldn't have worked. So if you can do split DNS, that's always preferred. But there are some cases where split DNS doesn't help, especially if you're doing port shifting, like you've got something on the outside on port 8080 coming into a local port 80. You're not going to be able to use the same link from the inside and the outside in that case, unless you do NAT reflection. So just some things to keep in mind, but we try to avoid NAT reflection if we can. So getting back to the firewall settings for NAT reflection, for port forwards, there are two modes, well, three. There's disabled, which is the default, and then there's pure NAT, and there's NAT and proxy. Of those, we recommend pure NAT because it's handled purely in PF. Of the two, it has the lower overhead. So, if you have to use NAT reflection, try pure NAT mode first. It's all PF, it's all NAT, nothing too fancy. By default, it doesn't do the source masking I mentioned, but there's an extra check option we'll get to in a moment where you can have that do that. So by default, it would work if say your servers are in a DMZ or clients are in the LAN. Pure NAT mode would work just fine for that scenario. You wouldn't have to worry too much. But if your clients and servers are in the same LAN, you'll have to check the automatic outbound NAT for reflection, which I'll touch on in a moment. The other port forward NAT reflection mode is NAT and proxy mode. In that mode, it actually sets up XINetD, and it sets up a bounce daemon locally for every port that you've got, every port forward you have active up to, I think, 500 ports in a range. or as many individual ports as you have. Now that's really not ideal because it's going to be consuming resources for all of those little inetd entries and bounce daemons and whatever that are running. And so, but every time a client makes a connection, it connects to that bounce daemon on the firewall, does the TCP handshake to that. Server accepts the connection. The server makes a new connection out to the server, and so that all automatically appears to come from the firewall itself because of how that traffic is originated from that daemon. So it's not actually forwarding the ports or the packets or anything. It's actually accepting that connection and making a new connection. So there are some cases where NAT and proxy mode will work with less intervention, but it's not as desirable as pure NAT mode. So only fall back to that if pure NAT mode doesn't work for whatever reason, and you really have to have NAT reflection. There's a reflection timeout knob here for NAT and proxy. It only works in NAT and proxy mode. You can kind of set a timeout there. You might want to set that a little bit lower to make sure that connections aren't being held open indefinitely on the firewall. All right, and then here we have NAT reflection for one-to-one NAT, which works similar to the pure NAT mode for port forwards. It adds PF rules that will bounce that traffic over. Again, just with that, it can work okay if your clients and servers are not in the same subnet. But then the real winner here is underneath this, the enable automatic outbound NAT for reflection. So you will want to activate that so that your pure NAT mode, port forwards, or one-to-one NAT reflection actually work fully. So that when the traffic leaves the firewall going to these other devices, it's going to look like it came from the firewall to ensure that that return traffic works properly. So most of the time, if you need any type of reflection enabled, you're going to want to have this box checked. So that's a very important one to consider. All right, well, we've talked all this much about inbound NAT. I'll talk a little bit about outbound NAT, and that's just under firewall, NAT, on the outbound tab. So, as I mentioned a little bit ago, outbound NAT changes the source address of a packet as it exits an interface. And the most common use of this, it's on by default, is to translate your private address LAN out to your WAN address as it leaves. And it does that overload style port address translation where it will just hide your whole LAN behind your WAN address so that you can get out. So it doesn't actually direct the traffic, it just controls that translation along the path it's already taking. So, and the most common use, like I mentioned, it's your overload style port translation. So you have all of your internal hosts getting out over a single address. And by default, the source ports on those connections are randomized, but you can override that with static port if you want. You just have to be careful with static port NAT. You don't want to overuse it because you can actually cause yourself a problem. If two local clients try to use the same source port to get to the same destination, only the first one's going to work and the second one's going to fail. It won't get a NAT state. It'll just it'll get shoved out without NAT. It's not ideal to see that happen. The most common case where you might see that is if somebody unknowingly or in an attempt to fix something else puts in a rule that does static port out for 5060 from IP phones. I mean, that's a good rule to have for PBX, but not IP phones. So if you're doing static port out on 5060 as a source, all going to the same remote PBX, then the first phone's going to work and the other phones are going to fail. So you don't want that in that case. You'd want to fall back to just using just randomized ports, not static ports for IP phones or something in that case. And if you do have a case that needs static port outbound, whether it's a game console or a PBX, you want to make sure you have those rules specifically match those devices and that you want to have them, toward the top of your list. You want to make sure you're not over matching for static port. So say you need to do static port for something, don't match your whole LAN doing static port out, match just the device you need to do static port from and just that, and do it at the top of your rules list. So we've got our modes here up at the top. You see we've got automatic outbound NAT, we've got hybrid outbound NAT, manual outbound NAT, and disable. In automatic outbound NAT and hybrid outbound NAT modes, automatic rules are kept here in this table at the bottom. And for the sources, they collect the list of network interfaces, uses your LAN networks, which are, or local networks, which are networks that are here on local interfaces that do not have a gateway set under interfaces and LAN, for example. You can have a gateway under system and routing, that's fine. It's just on interfaces LAN. You don't want a gateway set there. If you have a gateway set under, say, interfaces WAN, that defines it as a WAN, and that's going to be an exit interface. And then if you don't have a gateway, it'll be considered a local interface, and it will be used as a source for Outbound NAT. So it gathers those, and it also does like your VPN tunnel networks and like your IPsec phase 2 networks, things like that. And so it automatically makes a set of rules from your local networks, leaving your exit interfaces, your WANs. For each set of those, it does a static port 500 rule for IPsec, which is useful for IPsec pass-through for local IPsec clients going out. And it also does a rule that will catch any traffic and do just port randomization on it. So, and it will make a set of those rules for each WAN. Now, automatic mode just uses the automatic rules and it ignores anything here in the mapping section. Hybrid mode, hybrid outbound NAT is recent. It was in 2.2, but it is the best of both worlds. You get your automatic rules, but you can still make your manual exceptions to those rules. And so you have these rules at the top that you can control, and they are considered before the automatic rules, so you can make exceptions, change things however you want. And so it does both at once. Manual outbound NAT mode only considers the mappings and doesn't do automatic rules. If your list of outbound NAT mappings is empty when you switch from automatic or hybrid over to manual, it will make an equivalent set of rules there. It will actually make you a whole big giant list of rules that effectively have the same list as automatic, and then you can go through those and delete any rules you don't need. The use case for that is most commonly, say you've got several interfaces and maybe your DMZ has a routed public block on it. You don't want to do NAT outbound for that public block, so you would want to delete those NAT rules for the public block. You could do the same in hybrid mode by making a do not outbound NAT rule for the public block. Some people find that more confusing than going the manual route, but it's up to you. The main drag with manual outbound NAT is that if you do have a new LAN or a new WAN that you add later, you have to manually make your sets of rules for that additional LAN or WAN to have outbound NAT on there. It's pretty common. We'll see somebody adds a second WAN, says, well, hey, my second WAN's not working. I can ping out of it, but I can't get any traffic out. Well, come to find out, they're on manual outbound NAT and they didn't add NAT rules, and that's why they can't get traffic out. Same thing with like if you're on manual outbound NAT, well, I added a LAN 3 over here and I can't get outbound from it. Well, there's no outbound NAT rule and you're on manual, that's why. Lastly, there is our disable outbound NAT. Rarely used, but still useful. You would use that in cases where you have no local networks that are private. It's every network you've got locally is all routable. You don't want any NAT to happen outbound at all. And so you tick that over to disable and save, and then it wouldn't translate anything outbound. So a couple other things you can do with outbound NAT. You can do source restrictions. Normally you would just have your local network, like your LAN as your source. But as you can see in these examples here, I've got it set for a source of just a PBX, or in this case, just the mail server. You don't want to use a source of any as your source on an outbound NAT rule, because that will also NAT traffic from the firewall itself, which you really, really don't want to do. And that will really mess up like VPNs, IPsec especially, or in some cases we've seen it mess with gateway monitoring. It can't mess with CART because we have internal exceptions for that, but you got to be on the lookout for things like that. Traffic leaving from the firewall itself is already on a routable address. You don't need to translate that outbound to something different in most cases. There are some niche cases where you might want to, but more often than not, you're not going to want to do that. So you could make an exception above that do not NAT from the WAN address as a source, but you can't use the macros, so you'd have to actually, if you could only use that in cases when you got a static address. So again, not something you really want to get into messing with any for a source. Destination on the outbound NAT rule, your any destination means the intranet in this case, or you could be specific. Like in this case here, I've got the source of my PBX with all UDP traffic going to a destination of only my upstream SIP servers, and I'm doing outbound NAT with static port. So that's a very specific rule. It's only traffic from the PBX and only going to the SIP servers on that specific WAN has static port. Nothing else will get static port. And you can use IP aliases instead of IP addresses or subnets to help with large numbers of local clients. Like you could, instead of having a rule for each one of these individual networks, if you were in manual mode, have an alias that contains all these networks and then use that as the source. You can also use aliases and destinations like I've shown you here with this PBX rule. And you can also use aliases of IP addresses for outbound NAT to have a group of addresses to translate to. If you have a ton of local connections, let's say like a large hotel or a school, you've got a lot of local clients, you're going to have trouble getting them all to go out with one IP address. Eventually you're going to run out of ports to translate with. So you need multiple addresses. And when you do that, you can do it with a block of addresses. You could do that with an alias that has addresses in it. You're going to need VIPs for those unless it's a routed block. But you can get to work in like there's a round robin fashion, there's a randomized fashion. If you've got an alias of single addresses, you can only use round robin types, but it's pretty flexible in what you can do. But you'll find that in a lot of larger deployments. I'll show you that option here in a second. Again, going through an example here, before you start, you need to add any virtual IP addresses you need. And just, firewall NAT, outbound tab. Same with port forwards and one-to-one NAT. The rules are considered from the top down. First match wins. So if it's a more specific rule, add it to the top. A more general rule, like for a whole subnet, add it toward the bottom. There's a do not NAT box here, so you can do exceptions if you want. Interface is where the traffic is exiting. Protocol, as we've covered, it's suited to your needs, or you could just leave it as any. Your source network is going to be the local address that you're coming from, whether it's a whole subnet or a single address, you use type network. If it's a single address, you just use a subnet mask of /32. You can also do like a do not NAT rule with a source of self like that, and that would prevent your firewall from getting NAT in a rule like I mentioned where you don't want that. Destination filtering, same. You can do any as a destination or a specific network. You can also invert the destination match with that not checkbox. Now, translation controls what happens to the traffic as it's leaving. So the top part matches the traffic. The second part, the translation section, controls what happens. So more often than not, you're going to be translating to an interface address. You can also choose a VIP here, or you can choose an alias or a subnet. If I choose an alias, for example, just say SIP server, whatever. It's this alias is not suited to this. I just picked it just to get the options to show up. Your pool options here, you've got round robin, which just goes through and uses them in turn. You've got random, where it picks a random address from the pool. Source hash tries to maintain a relationship between the client and the address they're leaving, so it tends to use the same address. Bitmask sort of works closer to like one-to-one NAT, where it's trying to do an outbound one-to-one NAT on a group. You would almost never use that in an outbound NAT rule. It's there because it's possible, but you'd almost never use that. And the sticky on different types further tries to keep clients going to the same thing. It's not needed on source hash because that's sort of built into source hash, but like random was sticky or round robin was sticky, it tries to maintain a client relationship, client to IP relationship. Now, if you're using an alias, the only one of these that's going to work is either round robin or round robin sticky. So the port here, you're almost always going to leave blank because you don't generally want to force a connection to just have one port. Or you got a source port range. You could use that if you want to have a different NAT port range than the default. And then as we've talked about a bit, static port, if you want to do static port, just check that. And then whatever the client sends through as the source port, that will be maintained as it leaves. And then you can add your description if you want. That's just about it. Show you a couple of examples here. I've got this PBX rule just on the WAN, protocol UDP, source of my PBX, destination of the SIP servers, going to the interface address. I could have had that go to a VIP. This, just for that example, it was an easy thing to show. And because in this case, it was just going out and it just wanted static port. Static port was the reason for that rule. Now this one here is a mail server, which as I mentioned, I had a one-to-one NAT rule for a mail server, and I also had these outbound NAT rules, and I wanted to have the mail traffic go out this other VIP, and so I needed a rule to match on WAN, protocol anything coming from a source of my mail server, going anywhere on the internet, gets translated to that VIP. So if you had something like, say, a game console that you were looking to accommodate, a lot of game consoles need static port outbound, so you would match from a source of your game console /32, and to get that to a static address, you probably would have to use a DHCP static mapping. So do a DHCP static mapping, get it on a static address, specify that specific source, any source port. Usually a destination, if any, is going to be needed because odds are you're not going to be able to nail down the servers it's going to. Destination port of any, NAT address, probably going to be your interface address unless you're lucky enough to have a spare VIP. You could use it with that, but then you'd want to set static port on that. And again, you'd want to have that, a rule like that would be closer to the top of your list, if not at the top. In this case, in my mappings here, you can see all of my manual rules here for hybrid mode are specific source, so there's not really any advantage to the ordering. I see a couple of comments there about PlayStation 4 needs static port. Yeah, I know the Wii U needs static port for some games, but not all games. I know like Splatoon really wants static port. I had been using, at least on the Wii U that I've got, like Mario Kart and a few other things over time had been fine without static port, but once Splatoon came along, I added static port for it, and then that was happy, and everything else has still been happy. So it's pretty good. So just a couple of brief words about testing and troubleshooting, and then we'll move on to Q&A. So if you've got any questions that you need, you might be go ahead and start typing those out or prepare them for when I get to the Q&A here in a minute. When you're working with NAT and you're making changes, you're always going to want to reset your states after you make changes, because if there's an open connection, and this is especially true with PBXs and the UDP traffic in general, if there's an open connection, it's not going to obey your new NAT rules. You need to reset the states to kick it to use the new NAT rules. But for TCP, it's not that big of a deal because if a connection breaks and it reconnects, it's going to use the new rules as soon as you do it. But better safe than sorry. Get your rules set how you want and reset your states and make sure everybody's obeying your new NAT rules. You check your state table under diagnostics and states and search on the source address or the destination. Kind of see what's happening to the traffic. If you don't see a state entry at all, odds are maybe you didn't get to the state table fast enough after you made the connection attempt, or maybe it didn't get past the firewall rules. So you might need to check your firewall rules, or if you have a source restriction on your port forward, make sure it's passed through that. If it got a state entry, but you see it in the state table, but you see the NAT pointing it to the wrong place, then maybe it didn't match the right NAT rule, so you want to check your rule ordering, things like that. check your firewall rule restrictions or source port restrictions on your port forwards, and make sure that wherever you're sending this traffic from, that it's actually going to match your rule. So you're almost always going to have to test these from the outside somewhere. And so make sure you test them from the outside, and don't try to test them from your LAN, because that would be relying on NAT reflection, and it could be you're having a problem with NAT reflection, not your port forward. You could be looking in the wrong place for the problem. So always test it from the outside. Smartphones are great for that. Just send a little test request to like a web server, whatever, over your handheld over 4G or 3G, and they're great for testing stuff externally. So if all else fails, you can run a packet capture, like on your WAN. If you run a packet capture on the WAN, you don't see anything coming in. Odds are it's something upstream from you. Either your ISP is filtering it, your modem's filtering it, something is stopping that traffic before it gets to you. And so, you need to make sure that if you're not seeing that traffic, you're looking for external things, or maybe you've got a missing VIP. Somehow that traffic is not even coming to the firewall. If it's coming to the firewall, but you don't see it getting any further, that's going to be your rules, your NAT rules, firewall rules, something like that. If you run a capture on the LAN and you see the traffic leave LAN but not return, that's going to be a problem on your local device. The firewall's forwarding it in, it's doing all it can to get that traffic. But if the return traffic doesn't come back, odds are it's being blocked or mishandled on your local server. So it could be that it's got a local firewall. It could be the daemon's not listening on that port. It could be that it's using the wrong gateway. It could have some other broken network settings. So you see that packet leave the LAN. It's going there. It's not coming back. It's got to be something off the firewall in that case. So there's some more port forward troubleshooting suggestions on the doc wiki. I'm kind of a bit over time, so I don't want to get too much more into it, but figure we can roll on over to the Q&A now. So if anybody has any more questions, or if you want to see anything else in any closer looks at the examples I've got in this particular setup, just let me know in the chat. But that's all I really wanted to go over. I contemplated splitting this into a couple of different hangouts, but it was kind of right on the edge of having too much for one or not enough for two. But it all seemed to tie together. So. There will be a video recording of this up in the archive either later tonight or it could be Monday. It depends on when everything gets processed. The slides should be up there with it as well if you want to see the slides. Let's see, Pete says, good stuff, man. Thank you. Helpful with respect to aliases. Yeah, aliases can really help you with all sorts of stuff, making things easier. Makes your rules self-documenting. It makes rules easier to manage. You don't have to have 10 rules when one will do. So I'll poke around these things a little bit more while we're waiting on let's see if any questions pop up. I kind of wanted to have a couple examples here. So I've got, a PBX using port forwards, and I've got a PBX using one-to-one NAT, and then I had a mail server using port forwards and a mail server using one-to-one NAT. The PBX and mail server that used port forwards also had to have outbound NAT. So it's all fun stuff that ties together. I can make another separator here. Stuff. All right, see, I just want to clarify on outbound NAT, our WAN side is a /30 and we have a routed /29. I can use hybrid NAT and just create a rule for that specific subnet to not NAT, as opposed to having to create rules for all 6 subnets I have. Yeah, Mark, you can use exceptions for that if you want. Like if you're actually using that routed /29 on a local interface, you should be able to go into outbound NAT hybrid mode, add a rule to the top here that says do not NAT on WAN from a source of your routed /29, and that should make an exception. Tyler said, did we cover MPT IPv6 prefix mapping? No, we didn't cover that. I covered that in the IPv6 hangout we did a few months back. NPT it's hard to discuss NPT without also doing a lot more on IPv6. And for all intents and purposes, NPT is the same as one-to-one NAT for a subnet. So, but yeah, we did a whole IPv6 hangout, and I covered NTP pretty well, or sorry, NPT during that, because NPT works pretty well. I use it here. I actually have two Hurricane Electric tunnels, one on each of my WANs, and I use one natively, and I have NPT on the other, and I'm doing multi-WAN on IPv6. It's really pretty slick. I can't remember how much of that I covered on the hangout, but I remember delving into it a bit. Also, we generally discourage using any kind of NAT with IPv6, but in some cases like that, for Soho multi-WAN, you can't really get around it. Still got to use the prefix translation, but it's limited in some ways what it can do too, because you have to have static addresses. You can't use it, like say if you got prefixes being delegated to you from ISPs, you can't use NPT because there's no way there's no macro or way to say, you know, I want to use this particular track subnet here and there for translation. It just doesn't work right. So, all right. Anybody else? Any other questions or things you wanted to see? Does pfSense support carrier grade NAT stuff like LSN? I can't think of what LSN is off the top of my head. Let me look it up. Oh, large scale NAT. Again, I'd have to look up what that is. I don't. The only thing that might come close to that would be sort of what I mentioned on Outbound NAT, when you can do in your translation, when you choose, if you have a whole subnet to work with, you can NAT to a pool of addresses, and it will, you know, randomly or using an algorithm you choose, you know, map people to one of many addresses on the outside. So that's probably the closest you're going to get to something like that. Yeah, so I've only seen that used maybe, I don't know, maybe I could count it on one hand how many times we've actually seen that used in practice. But well, personally, between everyone here, we've probably seen it maybe a dozen times or so. But when it's needed, it's really handy. But more often than not, it's for larger scale installations where most people aren't going to see the need for that. But it's there if you do need it. All right, any more questions or anything at all? If not, I'm going to wrap it up. Says biggest pfSense deployment number of clients. I couldn't tell you off the top of my head. I wouldn't know. I know there's some that are running with thousands and thousands of clients, but I couldn't tell you exactly an exact number or even begin to quote an exact large number off the top of my head. And we only know some of those things because our customers tell us. Sometimes there are people out there running it in cases where we have no idea what they're doing, but we know it's very, very large, just, you know, because we've heard rumblings about it. Large companies or entities inside or outside of government that use it for various things, or it gets used at, you know, conventions and schools and hotels that have thousands of guests. But I couldn't begin to say what the biggest one is. Okay, well, I'm going to go ahead and wrap it up. It's been a pleasure. We'll see you back here next month. And if you have any suggestions for Hangouts or anything, just shoot us a note, either Twitter, the forum, Reddit, wherever. Just let us know what you might want to see, and we'll see everybody back next month. Thank you.